Alright, hi guys, so today we'll be covering a concept called linear law. It's basically the AddMath version of variation, which we covered in the last video. You should check that out if you haven't already. So basically, let's first think about what is linear law. Well, it's the process of converting a nonlinear function to a linear form that can be graphed in a straight line on, it's basically just straight line form you're converting it to. So what is the straight line form? What's the linear form of writing equations? It's essentially just y is equal to mx plus c. And if you recall, y and x are just variables you can just input based on coordinates that are on the plane. And m is the gradient and c is the y-intercept. So this is the form that we want to always convert anything we have to in order to linearize it. I don't know if that's a word, I'm just going to use it for now. So let's say we have the curve y equals 3x squared plus 4. So let's say we want to linearize it. Well, we can basically graph it as, that's not straight, let me do that again. That's not straight either, but whatever, let's just go with it. We'll graph it with y, and we can graph it against x squared. Normally, what we'd actually have is we should have a graph of x and y. But in this case, it's not linear. If we want to convert it to a linear function, we have to actually use x squared here because that's substituted in for x. Well, now we can take two distinct points and actually graph it on this plane. So let's just take, well, okay, first of all, what we should first make notable is that what we should first highlight is that we have to actually replace this with x. If we want to linearize it, we have to actually put it in a linear form. So we can actually just write it as y equals 3x plus 4. We can leave the axes as y and x squared because we're trying to linearize it, but we have to actually make this a linear function so that we can actually graph a straight line. So let's say when x is 2. When x is 2, 3 times 2 is 6 plus 4. So y is 10. So when x is 2, y is 10. Let's just say that this here is 210. 210. And now let's input another value. Let's say x is 3. Well, 3 times 3 is 9, and then plus 4, it's 13. So let's just graph that. Let's say this is 3, 13. And we can graph one more for good measure to just show it's a straight line. Let's say when x is 0, let's do the y-intercept. That's just 4. So that'd be roughly around here. 0, 4. And we can actually just graph a straight line going through all these points, and it shows that this is a linear function now. Well, how would we graph the original function now? Well, we'd use the gradient formula, which if you recall is y2 minus y1 over x2 minus x1, which means that we can actually just take, let's just take these two coordinates here. So using that formula, we get 13 minus 10 over 3 minus 2, which gives us 3 over 1, which is just 3. So if you see, we get the same gradient that we're meant to get here. And obviously the y-intercept we're going to get is 4. Now, we can essentially, if we want to get the original function, just substitute x squared back in there. And our function is now, again, y equals 3x squared plus 4. So they're not actually just going to give it so easily to us where we just, have to make it like this. Well, in an actual AddMath paper, they might say when y is graphed against x squared, a straight line is formed between these 2 points. Find the equation of the original line. And then you're required to actually deduce the gradient using the gradient formula of using those 2 points and find the y-intercept and then substitute x squared back into x to get the original function, which is this here. So let's try 1 or 2 practice problems just to see if we get the hang of it. Alright, so let's look at this problem right here. It's saying variables x and y are such that when the cube root of y is plotted against 1 over x, a straight line passing through the points 0.2, 5, and 1, 13 is obtained. Express y in terms of x. Okay, so this is, like I said before, kind of the equation or the question you're going to get in an AddMath style question. It's 4 marks. The first thing we need to do is write down our linear way of expressing the function, which is y equals mx plus c. And then substitute these values into y and x respectively to get the cube root of y is equal to m times 1 over x is just m over x plus c. And we really need to just establish, first of all, what we're trying to like graph. So we've graphed it like this, where cube root of y and 1 over x on the axes. Now we need to find m. And the way we do that is use the gradient formula for these two coordinates here. And I'm not going to repeat the formula. You should probably know it by now. And if you haven't, just go back a little bit and check where I just wrote it. So it's 13 minus 5 over 1 minus 0.2, which is equal to 8 over 0.8, which is equal to, and then we can actually just use we can use a calculator to do this. So let's just do it right, 8 over 0.8. That's just 10, which is a nice round number. All right, now we've got our gradient, which we can actually just substitute it in to get cube root 3 y is equal to 10 over x plus c. Now what we have to do is actually find the y-intercept. So when we substitute our values of x and y in, what do we get? What do we have to no? When we substitute our x and y values in, what do we have to do to get the y-intercept? Well, the way we do it is that we actually don't use this equation here. We use this linear equation. So our value of m is 10. So it's y equals 10x plus c. And now we have to find c. So let's just take this coordinate right here. So 13 equals 10 times 1, so 10 plus c. So that means c must be 3. So now we can actually substitute into the real equation to get our final one, which is cube root of y is equal to 10 over x plus 3. But we're not done yet. They're saying express y in terms of x, not cube root of y. Well, that's pretty easy. We can just cube everything to get rid of the cube root sign on the y, to get y is equal to 10 over x plus 3 cubed. And we can literally just leave it like that because it would be a bit painful to have to simplify this. We could use binomial theorem, of course, but let's just leave it at that. So that's our final answer for this question. Let's just do one more to confirm our understanding, and then I'll leave some worksheets or some practice questions to get so you can get some practice. Okay, so let's look at this problem here. Variables x and y are such that when the fourth root of y is plotted against 1 over x, a straight line graph is passing through the points 0.59 and 34 is obtained. Find y as a function of x, and it's 4 marks. This is essentially very similar to the one that we just did. So let's just first do the first step, which is write down the linear equation y equals mx plus c. And let's look at the values we'll be substituting. So y will become to the fourth root y, and x will become 1 over x, but that's later. We can first find the actual linear equation and then substitute these values in. So to the linear equation, let's use the gradient formula to find the gradient, 34 minus 9 over 3 minus 0.5, which is equal to 25 over 2.5, which is just 10 because you can just see this is 1/10 higher than the denominator. So our gradient is again 10, which is very coincidental actually, because I haven't seen these problems before. So y is equal to 10x plus c is our equation so far. Now let's substitute one set of coordinates in. Let's do this one. So 34 is equal to 10 times 3 is 30 plus c, so c is equal to 4. So our linear equation is y equals 10x plus 4, but our actual equation is to the fourth y is equal to 10 over x plus 4. And we can simplify this to make it y equals, and then we we raise everything to the power of 4 because we want to get rid of this the fourth root sign, 10 over x plus 4 to the power of 4. And we can just leave it like this. We don't have to use binomial theorem to expand it just yet. So yeah, that's this problem done. I'm actually going to give one more problem because these problems are really similar. So let's just ensure that we have a good understanding of any problem that were thrown. Okay, so let's look at this question here. It's a bit different from the ones we've covered, and it's a bit more difficult, but we can do it. The table shows values of the variables x and y such that y equals ab to the power of x squared, where a and b are constants, and we just have to find the equation of the line using this table right here. So the first thing we have to realize is that we actually have to find this into straight line form in y equals mx plus c form. And we have to actually write this in such a way that we can actually evaluate it. So we have to actually spread it out so that the mx are together, such that the mx are together and the c's together. They're all in one go at the moment. So we can actually use logarithms for this. This is the best equation to use. So we can use log y, and then we do that to everything. So it'll become log a b x squared. And we can use law of logarithms to solve this. So log y equals log a plus log b x squared. And we can use law of logarithms to bring this down. So log y is equal to x squared log b plus log a. And we've got everything we need to know. Basically here, this represents y. This represents our m value, this part here at least. Then this represents our x value, and this represents our y-intercept. So what do we do now? Well, we actually have to plot. Well, we can plot a graph of our two things, which is log y and x squared. So what do we need to do? We actually need to change the values here so that they're in terms of log y and x squared. So let's look at x squared first. Well, if we write this again, let's draw another table here where we can actually just do this. So our x squared value, so 1 squared here is just 1. 1.5 squared is, I think, 2.25. Let's just draw a line like this. Then 2 squared is 4. 2.5 squared is 6.25. And let's just stop there. We don't have to do every single value. Then for log y, we actually need a calculator to evaluate this. So let's just get the calculator. And what we can do is just do log of the values here. So log 6 just gives us 0.7. We can just do it to 2 decimal places, to 0.78. Then log 14.3 is 1.16. Log 48 is 1.68. And then log 228, is 2.36. And now we have enough coordinates that we can actually just use the gradient formula. So let's just take this point and this point here, just because they have a whole number for the x coordinate. So 1.68 minus 0.78 over 4 minus 1 is our gradient, which is, and then let's just do this on our calculator, 1.68 minus 0.78. That's 0.9, so it's 0.9 over 3, which is equal to 0.3, which is a nice number as well. So right now we have y equals 0.3x plus c, which is our y-intercept. Let's take one coordinate and just solve for c. So let's just take this one here. So 0.78 equals 0.3 plus c. So c is 0.78 minus 0.3, which is equal to 0.48. And that would work if we put in any other value of that too. So our equation is y equals 0.3x plus 0.848. But remember, we have substituted values over here. So our c value is actually log a, as shown by this. So 0.48 we have to equate to log a, which means that a is equal to 10 to the power of 0.48, because that's how logarithms work, which is equal to 10 to the power of 0.48 is equal to 3.02, which we can really just represent with 3 if we want, but we can also just do 3.02 if you want to be more exact. Well, now let me make a bit more space here because we've run out a lot of it. So I'll just write this down here. A is equal to 3.02. And let's find now what the value of m is. So we can see that our gradient is 0.3, but that's also equal to log b as per this. So we equate the two. So 0.3 is equal to log b, which means that b is equal to 10 to the power of 0.3. Let's just do the same thing with a, which means that b is equal to, so we did the same thing with both of them because they're both in logarithms, and we can actually just raise them to the power of 10, whatever we get for this, to get our value of b. Because if we raised this, because we're raising both sides to the power of 10, right? These two sides. If we did 10 to the power of log x, 10 to the power of log b, that's just the same thing as b. So that's why these two are equal here. So b is 10 to the power of 0.3, which is 1.995, which is just the same as 2. So we can actually just say A is 3 and B is 2. Now, why don't we just substitute the values into our original equation. Let's just do this here because there's more space. So that means what y is equal to 3 times 2 to the power of x squared. That's our final answer. So yeah, that's linear law for you. That would be one of the harder questions you'd get. If you have any questions around it you'd like me to help with, then do let me know in the comment section below. And otherwise, yeah, thanks for watching and see you in the next one.